Welcome back to transformation of functions. So this is our part 2. So let's continue. For this example, this is a what type of basic common function. So I'm just kind of moving down the list here from this particular video, the types of common and basic function. So just by looking at it, I believe you recognize that this is an absolute value function. So what type of common function it is? It's an absolute value function. All right, let's take a look at our transformation. Vertex, so I mentioned the vertex before in a different videos. So the vertex, let's see, x minus h. So remember the form a times x minus h. Ooh, not a parenthesis, but absolute value symbol plus k. So right now, again, was inside the absolute value, the x minus h is not quite x, it's a half x. So what I'm going to do here to know whether I shift it to the right and left, I would need to factor out my half. So for the half x plus 2, if I factor out the half, that should give me x plus how much? Well, remember, factoring is division. Half going to half is one time. Half going to positive 2 is positive how much? Half go into 2 means 2 divided by half, which is actually 4. Okay, so that means that inside the absolute value, can be rewritten. Let me try this. What's inside the absolute value can be rewritten as absolute value of half times x plus 4, then minus 3. Okay, so now matching the form x minus h, so my vertex got to be negative 4 as my h. My k is negative 3. So that also tells me at the same time, my graph has shifted to the left 4 units. That's what the vertex, the bottom of the V has shifted to the left 4. And my vertical shift is actually down 3 units. Okay, so by knowing the vertex, that also tells me how is my transformation, how my horizontal and vertical shift has gone to. All right, reflection about the x and y axis, that's referring to in front of my function, what is it? Negative. Let me go back. All right, if the negative sign is in front of my function, that's reflection about the x-axis. If the negative sign is inside of my absolute value in front of the x, that would be y-axis reflection. So I believe this one, there's no negative sign in front of my absolute value. There's no negative sign in front of my x, okay, because it was a positive half. So I actually don't have any reflection about x or y-axis. All right. Does the graph of absolute value function stretch or vertical? Stretch vertically, compress vertically. So vertical compress or stretch, that's referring to the coefficient in front of the absolute value, which I don't have a number, which is a 1. Okay. All right. In front of the absolute value, this is actually 1. So I don't have any vertical compress or vertical stretch. Horizontal stretch and compress, that's referring to the B, the coefficient inside my absolute value that's in front of the X. So in this case, in our example, it's a half. So half is between 0 and 1, so that will be stretched horizontally. All right, find the x-intercept. All right, let me show you how to find the x-intercept real quick. So let me write down my function again. So x-intercept, find x when y equal to 0, absolute value of half x plus 2 minus 3. All right, solve for x. So if you took our Math 108, this is in module 9, solving absolute value equation. So I need to isolate my absolute value term first. So I'm going to move my -3 to the left side so I can get my positive absolute value term by itself. So that's 3 equal to absolute value of a half x plus 2. Whenever we're solving for absolute value equations, okay, we'll need to set it up as set it equal to a +3 and a -3, as you can recall. So we set what's inside the absolute value equal to a +3, and set what's inside the absolute value equal to a -3. So we will solve both of these equations simultaneously. Let me move that down a little bit. There we go. All right, so let's solve real quick. Move my +2 to the other side. And I get half x equal to 1. The other equation should be half x equal to -5 times both sides by the LCD 2, or we can say times the reciprocal. X is equal to 2. The other one, x equal to -10. All right, so my two x-intercept, -10, 0, and 2, 0. All right, find the y-intercept. Find the y-intercept means find y when x equal to 0. So there'll be absolute value of a half times 0 plus 2, then -3. So half times 0 is 0. Absolute value of +2 is 2. 2 minus 3 is -1. So my y-intercept is 0, comma -1. All right, let's sketch using our vertex, x-intercept, y-intercept, and transformation of function. So let's take a look. Vertex, -4, -3. -4, -3, 1, 2, 3. That's right here. All right, my V is still going to be opened up because I did not have any reflection about x-axis or y-axis. -10 and +2. -10 and +2, 1, 2. My y-intercept, 0, -1. That'll be right here. So just to sketch it, I can just, well, I got enough point, I can do it. So this V go that way, and this connect right there. All right. So open a little bit wider than usual, right? Because I do have a stretch horizontally. All right. Find the range of the absolute value function. Domain for absolute value function is always the same. So that's why I'm asking for range. So the range is going to be down and up. So the very bottom point is my vertex, -4, -3. So that'll be from -3 using bracket, keep on going upward to infinity. All right, let's try another one. So what type of function is this one? Let's look at the big basic picture. This is going to be x to the third power 1. All right, this is going to be x to the third power because here I have an x to the third right here. So if I multiply this whole thing out, it's going to end up to be x to the third. But I'm not going to do all that. This is too much work. All right, so this is going to be a cubic function. And let's see what the graph would look like originally. All right, going this way. So I'm just going to draw it out so I can have an idea. All right. And so I didn't graph the absolute value earlier because I know absolute value function is going to be a V. All right. So to do the transformation, let's rewrite this inside real quick. This is going to be -x minus 3 to the third power plus 1. So to match up with the x minus h form, I'm going to say, because by looking at this -3, most students say, okay, I'm going to shift to the right 3 places. That's if the x is positive. My x is negative right now. So if I rewrite this again by factoring out a negative between the -x and -3, that will give me x plus 3 to the third plus 1. So the plus 3 here actually tell me I shifted to the left 3 units. Plus 1 tell me shifted up 1 unit. All right. There is no negative sign in front of my function, in front of my x to the third term. So it's not a reflection about the y-axis. But the negative sign is actually inside my function, inside of my to the third power. So if it is inside my third power, excuse me, so that'll be a reflection about the y-axis. I say it wrong earlier. Negative on the outside is reflection about x. Negative in the inside of my x to the third power is reflection about the y-axis. So that will be about y-axis. All right. So there's no other numerical answer in front, so that I don't have any vertical stretch or compress. Okay, now look at inside my x to the third power function here. This x, okay, the negative sign here tell me it's a reflection about y-axis. All right, but the coefficient, the b is actually not bigger than 1 or between 0 and 1. It's actually exactly 1, so I don't have any horizontal stretch over compress. All right. All right, now let's find the x-intercept. So find x when y equal to 0. So that'll be 0 equal to negative 3 minus x to the third power plus 1. So I only got 2 terms on the right side. So what I'm going to do is move my positive 1 over. So I can get negative 1 equal to negative 3 minus x to the third. So to get rid of the x to the third power, I can actually take a cube root on both sides. When we take a square root on both sides, the answer got to be positive and negative, but not when we take an odd root. Taking the odd root does not actually give me a positive and negative. So cube root of negative 1 would just be negative 1. Cube and cube root canceled out. That's negative 3 minus x. So now I'll move my negative x over, move my negative 1 back to the right side. My x is equal to negative 2. All right, so I got one x-intercept, negative 2, 0. All right, y-intercept, find y when x equal to 0. So that will be negative 3 minus 0 to the third plus 1, which is negative 3 to the third is actually negative 27, I believe. Plus 1 is negative 26. So that will be 0, comma negative 26, which is way up there, way above my graph. So I'm just going to kind of sketch it here just a little bit. All right, sketch the cubic function using x-intercept, y-intercept, and transformation of function. So reflection about the y-axis, okay? The picture was this way. The regular x to the third is this way. Reflection about the y-axis, okay? That means fold this picture horizontally, so that actually imprint to the left. All right, I'm show you what it looked like. Well, I'm just going to draw it. It should look like this if I imprint it. But if I actually fold my paper from horizontally, let me show you. All right, I'm going to type in a regular x to the third. Then I'm going to show you the one. Regular x to the third look like this. All right, now my function, I'm putting on the y2, negative 3 minus 3, close parenthesis, raised to the third power, negative 3 minus x. Okay, go the other way, see? Go the other direction. All right, so I kind of know what it looked like. So let me plot my points. What was it? Negative 2. Okay, my y-intercept is way down there. Okay, so I'm not even going to worry too much. I'm going to just put it down here. All right, so the picture looked like this. Let me kind of sketch a little bit better. It's coming from this side, this way, and it's not going to cross over the y-axis until it hit right here. Something like that. There you go. All right. Try another one. The square root one. All right. Radical function normally looks like this one. So you can say this is a square root function. You can say this is a radical function. With even roots. So if you want to be more specific, you can say square root. I'm going to be more generic, radical function with even roots. All right, so let's do our transformation real quick. So I need to rewrite this a little bit. F of x, let me put it down here. F of x equal to half times square root. I'm going to go ahead and write this as 2x plus 4. I'm going to move my x term up front. And minus 2 on the outside. All right, so let's rewrite this, okay? Inside my square root, x minus h. Not quite saying x minus h right now, so I'm going to factor out a 2. So that gives me x plus 2, okay, minus 2. So when I'm thinking about the form, all right, this is your a. That's always on the in front of the function. B is inside the function that's in front of my x, and my x minus h plus k. There you go. Write it like that. All right, so now we can answer our question a little bit easier now. All right, where do we shift it to? Right or left? Plus 2 means shifting to the left 2 units. All right, up or down? Minus 2 out here. The k, tell me shifting down 2 units. All right, reflection about the x or y axis. Well, there's a positive half and positive 2. So it's actually not going to reflect x-axis or y-axis. Those reflection about x and y, you got to have a negative sign either in front of your square root or inside the square root in front of the variable x. So that will be none in this case. All right, radical function stretch or stretch, compress vertically. So your a is a half. So if the a is a half, which is actually going to be compressed vertically. Oops, sorry. Your b is actually a 2, which is bigger than 1, so that will be compressed horizontally. All right, compressed horizontally. Oh, did I say stretch? And I wrote down compressed. Yeah, A is a half. A is a half, so that will be compressed vertically. B is a 2, which is compressed horizontally. Okay, so I wrote it down correct. All right, let's find the x-intercept. Let me move this down a little bit. Find x when y equal to 0. So I'm going to say 0 equal to half times square root of 2x plus 4 minus 2. I'm going to isolate my square root term by moving negative 2 over. So that will be 2 equal to half times square root of 2x plus 4. Get rid of the half in front of the square root, times both terms by 2. So that gave me 4 equal to square root of 2x plus 4. All right, to get rid of the square roots, we've got to square both sides. So that gave me 16 equal to 2x plus 4. Subtract 4 on both sides, divided by 2. That's 12 divided by 2, which is 6. So my x-intercept is at 6, comma 0. Y-intercept means find y when x equal to 0. So 2 times 0 Oh, let me write it down. There's a lot of that. Half times square root of 2 times 0 plus 4 minus 2. 2 times 0 is 0. Square root of 4 is 2. Half times 2. Half times 2 is 1. 1 minus 2 is negative 1. So my y-intercept is 0, comma, negative 1. All right, so 6, 0 is my x-intercept. 0, negative 1 is my y-intercept. All right. Shift it to the left 2, down 2. Left 2, down 2. That will be right here. All right. Can you imagine? Set was inside the radical equal to 0. So we know where the function began. So if you set equal to 0, I bet the x value will be negative 2, which confirms our horizontal shift as well. All right, so I know normally the graph look like this way, go up. So I'm just going to start right here and go to the right. Okay, going to sketch it. So my domain got to be from negative 2 to all the way to the right. My range, remember my vertical shift was down 2, right? Left 2, down 2. That kind of tell me where my starting point is. So that would also be negative 2 to infinity. All right, one last one. Cube root functions. Okay. So this is a radical function with r roots. Or you can say cubic function. Either way, but being more generic, I'm saying it's not a bad idea. So I know my picture will look something like this way. Just like this one right here. Okay, so let me write down my function so I can begin to find all these. So this particular example, I don't think there's anything we need to rewrite because inside your function is x minus h. Okay, the x is 1x already, so I don't have to do anything extra. All right, my b is 1. My a is just 2. All right, so plus 5 here. Tell me I shifted to the left 5. Plus 2 out here means I shifted to the upward 2 places. Okay, I don't have any negative. My a and b is not negative, right? They don't have the negative in front of my function or in front of my x that's inside the cube root. So this is none. All right, vertical. All right, this is going to be a, since a is bigger than 1, so that will be stretched vertically. All right, b is 1, so there's no horizontal compress or stretch. All right, let's find the x-intercept. Find x when y equal to 0. All right, move the positive 2 over. That will be negative 2 equal to 2 times cube root of x plus 5. Divide, I only got 2 terms here, so I'm going to divide both sides by 2. Excuse me. All right. So to get rid of the cube root, I'll just cube both sides. Negative 1 to the third power is still going to be negative 1. So that's negative 1 equal to x plus 5. So x equal to negative 6. All right, so the x-intercept, negative 6, 0. Y-intercept, find y when x equal to 0. This one is a little bit trickier because this is going to be 2 times cube root of 0 plus 5 plus 2. So that's 2 times cube root of 5 plus 2. So I have to approximate this a little bit. So let's see what that's going to be. So this is my exact answer, but I still need to kind of know approximately where that's located in order for me to plot. So 2 times cube root of 5, close parenthesis, and then plus 2. That's about 5.4. Okay, almost halfway between 5 and 6. Almost halfway between 5 and 6. So let's put about right here. All right, so the y-intercept, to be exact, that's going to be 2 times cube root of 5 plus 2, comma, backwards. 0, comma, 2 times cube root of 5 plus 2. So I do expect you to write me the exact answer, okay, on the quiz. But when you plot them, you can use the approximate answer to plot them. They'll give you a guide, where the y-intercept or x-intercept going to be. Negative 6, 0. Okay, so I don't have any reflection, so the picture will still look like this way, but it's just going to be shifted left 5 and up 2. Left 5 and up 2. So this is 1 point on the graph. So to know exactly what this thing looks like, let's still graph this function, okay? So I can draw my pictures more accurately. So that's 2 times cube root of x plus 5, close parenthesis for the cube root, and then plus 2 on the outside. Okay, look like this. All right, so part of my graph was under the x-intercept and come up. So that will be something like this. Okay, that's close enough. Alrighty, so just quickly show y'all how to do transformation of functions and insert some of these domain and range and x-intercept, y-intercept. These part, the back end here does kind of help me to do some graphing. But the point of the objective here is to be able to look at your function and know, okay, what the transformation is. Okay, so that gives you a very good idea what the picture is going to look like before you even graph them. All right, that will conclude this video. Thank you for watching.